Going on now to topic 2 of Unit 2, we're going to be dealing with linear functions. And again, you're going to keep this in your homework log, and we will be checking it. So for example 1, we're going to give you a little bit of background here. There are a couple of major words we've used. One is a relation, and you can write this up again. Another word is domain. Another word is range. And the last word we used was function. Now in mathematics, all these have a special meaning, and we'll just give you a quick review. A relation is any connection between numbers. That would be a relation. One of the most famous that we'll be studying in this section is the ordered pair, where we have an x and a y. Now, the x item in any ordered pair is considered the domain. The y element in any ordered pair is considered the range. And if the x element in any series of relations is only used once, this is considered a function. And we defined all these in our flipped classroom video. So, looking through this statement, a relation is a domain. No. Horizontal. No. A set of ordered pairs. Haha, there we are. So let's put that one right in there. Click on that, it'll go there, and that should be the answer. Now notice a number of these other words that we're using here, just to help with definition. Dependent. A little later in this, you're going to see this type of equation where this y equals mx plus b. We'll describe this a little later in our review. But there's the x. Now, as we make a t-chart and put in various values for the x term, like a 0, a 1, a 2, a -1, these values, or the x value, are considered the independent variable. And then once you put that independent into this machine here, this function, this rule, you get a y value. So the y value is dependent on the independent value of x. And that's what they're referring to here in dependent and independent. And to define linear, these would be equations and numbers that result in straight lines. Okay, lots of review here. Let's go on. Now, in example 2, again, you're going to put a box around it. Write this down. This is in function notation, where we're saying the function of x is this rule. Now, what would it be when we put a 5 for the x? Well, we just do a simple substitution. And we get 35 plus 2 is 37. All right, let's go on. Now, you want to have a protocol for doing these. So there's your function. and our x value is -2. So setting it up like this is a good methodology. We're going to put our x value right there, which is a -2. And according to our protocol of what do we do first, exponents, and our base is -2. So -2 times -2 is a +4. 4 times 3 is 12 now, minus 4 equals 8. And that's what you would put here. Again, we're showing you, modeling for you, the protocol strategies for this. And a little review never hurts. They're using the word output here in this example of this function. Again, the input is our x value that we put into the rule, which is this, and then the output is our y value. Again, x is the independent variable, y is the dependent variable. So if we put a 0 in there, this one we can do mentally. 4 times 0 is 0, so this is just going to be -4. And again, these are your homework questions. Similar examples of the 20 or so that you're going to get to give you, again, some hands-on practice as we go through our lessons. Now, a little more review. Here we're going to graph this function. And again, it's a linear function. It represents a line. Now, what we do for something like this, and keep in mind we said it's in a regular graphing unit would have this formula, y equals mx plus b, where m is the slope of the line and b is the y-intercept. It's where the line will cross the y-axis. And we make a little t-chart to do this often, saying that we'd want to use 0, and we might use let's say a -1 and a +1. So mentally, we're going to put these values into this simple equation. Now, if x is 0, 5 times 0 is 0, so y would then be a 1. And remember, we said this function symbol can always be replaced with the letter y. Now, if this is a -1, 5 times -1 is a -5, plus 1, this is a -4. And if this is a +1, this x, 5 times 1 is 5, plus 1 is 6. So now what you'll be doing is clicking on this little circle here in your homework. It makes the graph bigger. And then you're going to touch the screen in two places. Well, one place, and it's kind of small, but we'll do the best we can, is 0, 1. So we start at 0, and we put a dot right there. And then -1, -4. So we go to the left, -1, down to where -4 is, and it's right there. And then we go a +1 for the x, so over 1, up to where 6 is, and we put a point right there. Now, there will be a lined tool that you'll be able to use that gives you a nice line going through these points, and it just extends for the full graph. I'm off there a little bit, but you'll have the better tool for it. Now, there are shortcut ways that we'll be mentioning, and I may mention it here, but for this one, we will just go on. Now, as we do this one, again, it's in function notation. We could change it to regular graphing notation, y equals a negative 2x. Now, since there's nothing in the B position here, that's just a 0. So if we put a 0 as one of our values, if x is 0, negative 2 times 0 is 0, then y will be 0, and our y-intercept, 0, 0, is the origin of our graph, which is where the two lines intersect, and the ordered pair is 0, 0. Now, if we put in there a negative 2, if x is a negative 2, negative 2 times negative 2 is a positive 4. If we put in a positive 2, negative 2 times positive 2 is a negative 4. And we often like to do 3 points. It gives us greater accuracy in our graph. So let's plot these other points now. Negative 2, 4. So negative 2, it's kind of hard to see here. And then up 4 is about like that. Kind of hard to see. And then 2, negative 4 is like around there here. And again, we're getting another straight line going through the origin. And I'm off a little bit there, but you get the idea. And you want to make a little quick sketch here. If you wanted to sketch this, just put 2 lines, and then you're going to put your points in. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 2, 3, 4. We have one here at 0. And then a negative 2, 4 up there. Positive 2, 4 down there. And then your line. Actually, this is a better one because the points are a little further away and it's easier to graph. But you get the idea, hopefully. Again, if you have any questions, be sure you're asking, because I know I'm asking questions. Now, for number 7, there's a lot being asked here. Let's see what we need to write down. Find the value of x in which the function, and that would be the y, is equal to 60. And then they give us the rule here. But we know now this is going to be 60 equals 9x minus 3. So they want us to find, if we know y is 60, what would x be? So we're going to add 3 to both sides. So this becomes 63. Here it's 0. And now we're going to divide both sides by 9. 63 divided by 9 is 7, because 7 times 9 is 63. So our answer here is when x is 7, y is 60. So 6 times 9 is, or I should say 9 times 7 is 63, minus 3 is 60. So we've solved that. Again, this is sort of intensive. We're going over lots of things here, but we're just touching on it, and hopefully you're seeing a protocol for getting answers. Now, this one question is in 4 parts, so we'll do much of it together. So a person's going to operate a delivery service. He figures his startup cost is going to be $2,200. He estimates that it cost him, in terms of gasoline, wear and tear on his car and his time, $3 per delivery. Now he's going to charge per delivery $5.50. So again, we went over this in some detail, and we want to set up a cost function. So cost would be C of X equals every delivery he makes cost him $3, and X is the number of deliveries. And then he has his startup cost, which is a fixed cost, of $2,200. So that's our cost function. Now, what's our revenue function? Well, revenue function is that for every delivery, he's going to charge $5.50. So this is our revenue function. Now, determine a value for X for which revenue equals cost. Well, if we take this part and equal it to this part, that is our break-even point. So let's do that over here. 3.00x plus 2,200 equals 5.50x. So there is this part, which our cost equals revenue. We want to find out what value of x would be the break-even point. So we subtract 3x in a sense from both sides, and on this side we get 250x equals 2,200. Now I'm going to take my calculator and divide both sides by 2.5, and as I turn my calculator on, I put in there 2,200 divided by 2.5, and my answer then for x would be, when I do 880 deliveries, I have broken even. So if I do 881, I've made a profit. Now they want you to graph this, and you're going to be picking out a graph. So basically your revenue graph will start at 0 because your origin is 0, and we'll say looks like so. Now your cost graph starts here at 2,200, and it's going to go up like so, and there'll be a point of intersection. Well, we know down here our x value for this is going to be 880, and this over here is 2,200, and we want to see where they're going to intersect, and this would be a representation of the graph. Okay, you'll have your homework and your exercise, and be sure to ask questions if you're not sure of something.